now. Together we'll redefine the game. With NEAR we'll fan the flame. Empowered minds rise and soar. Use your own AI, we'll explore. Help the future hand in hand in this tech-driven wonderland.
Okay, I guess we're live. Great to have everyone joining us at the episode number
8-ish.
I guess. We're here from sunny and pretty hot Marrakesh at the NEAR.AI offsite and brainstorming and kind of co-developing. And so we're going to dive into some of the stuff we've been working on and some of the problems we're trying to solve. As usual, not prepared by design. And so you're going to be learning with us what are we doing. So yeah, let's dive in. Kind of the problem statement we started with was given a user who wants to build something and a language model, how do you actually get it to build what user wants? And Alex built a so
far. I guess we started by having everybody build a version of Devon. None of them worked very well. We have certain constraints which not everybody has. One of them is we're only using open source models. Particularly, we're mostly using Llamas. We tried to do Mistral, and Mistral wasn't as good for this particular purpose. And we narrowed down the scope right now quite a bit to only building console applications because they're easier to test. You can, once you nail that, you can add browsers and whatnot. Right, and what interesting did we learn? Well, one thing is good prompts matter, and models, work much better if you give them examples of what you want from them. Second thing we learned is that if you do not restrict yourself to open source models and do replace Llama with GPT-4, it does perform much better. So there is something to be done about access to user-owned AI for everybody. So I guess some effort to build larger community-owned models is in order. Couple other things. One is that as you develop, it takes quite a bit of, the model is like talking to itself, right? And it takes a lot of context to do that. And even if you have longish context, you run out of it. So you need some way of compressing it. That's actually quite a fun problem that we've been playing around with. Again, the only thing we really tried is trying different prompts that say, hey, look at this big context and make it small. But again, good prompts matter. And something we are about to launch, and we will announce it somewhere, but as a
live watcher, you get early access.
Well, I guess, yeah. We will have some sort of code to get your early access. But one interesting hypothesis we have is that if you keep, so the way kind of we call it Zella agent, and the way it works is it begins with the task specification, and then it thinks out loud, and as it thinks out loud, it has access to certain tools, and right now the set of tools is very restricted. It's reading files in the file system, writing files, and executing commands in the console. In this period of living life only once, I'm running it on the same machine on which I have keys to all my crypto. And
so it already made its own home somewhere.
Yes.
So escape.
And as it does that, at some point it runs out of context. And when we see that it's almost out of context, this is where we invoke the summary module that says, hey, look at all of that, and write enough text so that you forget of all of that, including the initial task. But you still have access to your environment. You can continue working, right? And
yeah, so there's some kind of environment that it writes, reads, execute commands, run tests. And so this environment kind of persists.
Yeah, the environment is still there, but the history is gone. And when you play with it, it's generally not great, but it's not bad either, right? It's actually making quite a bit of progress, and it can write some very cool stuff. But summaries is the biggest failure mode, right? So like if it messes up here, it usually is capable of recovering. Not always, but most of the time. But if the summary is messed up, there's no recovery, right? You don't have access to history anymore. So the hypothesis is the following. The hypothesis states that Llama 7TB or code Llama 7TB is good enough at doing this. Like let's say it has infinite context and it's very good at using it. The hypothesis is that it will be able to recover from any failure by like repeatedly reflecting on what it's done and like interacting with the environment. But the summaries need fixing, and so we will make humans fix them for us, right? So we will launch very soon on NEAR a project where everyone can earn some NEAR by making better summaries given the actions of the agent in the environment. And then, yeah, like the idea here is that, yeah, it's going to be a not that great model thinking out loud, but a very good model doing the snapshots. And then we will see what happens. Like maybe in a couple of office hours, we will have.
Well, maybe the way to kind of formalize it a little bit, right? Like
Before you go, just like the ultimate goal is not to be building console applications. The ultimate goal is to be building smart contracts and front ends and you name it, right? It's just console application is a very good self-contained task. Like until we can write a Python script that, implements a game of tic-tac-toe, we're definitely not there to build a contract. Sorry for interrupting.
Mostly can, but yeah. But yeah, I mean, because this requires also writing tests and making sure that it runs correctly, and in a way, a lot of the even smart contracts end up being kind of resembling command line tools. But yeah, maybe to formalize it, right? Like we have some task, and it is able to run for a while, interact with the environment, and in a way, like this is just another session like this as well.
Right.
It gets an environment which here it's also can be not empty.
Yeah. Maybe there was something. Yeah, maybe it's on the first one. Yeah.
Yeah, and so in a general way, right? It's like you dropped into some file system folders with some already files written, and you're given some summary of what's going on and what you should do, and you should be able to do it within some period of time, or be able to kind of summarize it such that somebody can follow from there. And yeah, I mean the benefit here is like then you can even open any project, right, that already exists and say like, well, here's the
summary.
Here's the summary, and here's what you need to do, and you can send it to actually try to fix a bug or implement a feature in existing code base. So it is a kind of general enough framework for being able to operate on kind of a code base.
And yeah, I guess we don't necessarily believe that this is the best approach to doing that. The idea here is to build infrastructure where we can very quickly iterate on those ideas, right? So like, as we right now work on it, is it open source yet? Not yet, right?
Not yet, no.
It will be open source very soon, but like we have, like building such an agent in our infrastructure right now is extremely simple. You like drop a small Python file, you say, hey, like environment start with that agent, and it's like doing all the stuff, and the same for data annotation. So like the idea is that if we think that a particular set of data would help us, the idea is that you should go from idea to humans already annotating it in like a couple hours, which is not quite the case yet, but we're getting there.
Well, and it's a combination of, right, you have environment as a kind of place you can run agents, right? And this doesn't need to be one agent, it can be a whole host of them. Then this can be run in few modes, right? Interactive mode, where as a user you also can either help with this or even help it with kind of its own process and thinking. So user, you can run it in so-called kind of task, where you just tell it to go and do it. And you can run it in benchmarking mode, where you actually have a data set with a set of tests where you're given an environment and a task, and it runs it maybe multiple of the sessions, and then when it completes, you can run on set of tests it hasn't seen to validate that it actually done the correct job. And so this is important because this allows to now, when this is open source, anybody to go and kind of play with it, propose different agent framework, kind of agent setups, as well as different ways of these interactions happen. As well as you can inject here, obviously, an LLM or multiple LLMs. And this is where you can swap to a fine-tuned model from some data to actually have, for example, if like summaries are written by a dedicated model that is fine-tuned on specific examples. So that's kind of the framework that been designed. Obviously, there's sessions recorded and then can be used as well for training and fine-tuning. Now, the interesting question is, looking a little bit ahead and analyzing some of the failures in general with LLMs, both in open source ones, but even in the closed source from what we've seen. So maybe we can look at that, as well as there's been some new research that has been published around kind of various search techniques and some of the reinforcement learning, both from human and from synthetic data, which also can be interesting to explore.
Any initial?
Yeah, so maybe just like as a simple, right now, you give a model a task, right? Like if you give to LLM, and you can, it can just be able to answer it. So this kind of direct mode. You can say, think step by step, and provide me an answer after. It's called chain of thought. Now the problem with chain of thought is that sometimes it kind of gets into a
Stuck.
Yeah, it gets stuck itself, and because it keeps attending to what it just thought about, it keeps kind of in that loop. And so one of the ideas was proposed, it's called tree of thought, where, as you kind of unrolling tokens, right, let's say, you can, unroll M or will, for example, the second most probable or third, and then you're kind of unrolling like few different options of this thought process, and then you're evaluating, few of these paths for actually giving you an answer, or you're kind of getting all answers from here and then scoring them in some way as well. Now, doing that on a token level is pretty expensive. It's also kind of the challenge I see with this is that it probably still will just select same semantic meaning, just like a different token that's kind of close enough to that, right? Like, it will not actually try to think in a different way.
I think it's also interesting. So, like, one idea, when I was thinking about anything related to cheese with the ranking, I was always thinking that there would be a separate network separately trained for it that tells you how good it is.
Yeah.
Right, but like as we were reading, I would not recall the name of the paper. They say you just ask the model to rank it, right? And in the example here, one of the that we just erased, but it wasn't that high fidelity anyway. One of the things that we observe, for example, is you say build me a game of checkers, right? And as it works, it can confuse itself. It can confuse itself in a very interesting fashion, which is in the game of checkers. Sometimes the promoted piece is called a king or a knight. A king, right? Kinging. Yeah, king. Or knighting. Anyway, let's say a king. And once it names it a king, it gets confused and starts building chess. And we wanted to see, we're like, well, that's a great example, right? We see a failure. The model was asked to build a game of checkers. It didn't get to the summary yet. It has the whole history in the context, but it converged to building chess, right? And we're like, this is a great example to test the ranking function. We give it the implementation of chess and say,
It's just checkers.
your task is to build checkers, give us the rank. And it's like, this is not an implementation of checkers, it's more of an implementation of a chess, but looks pretty good, 6 out of 10. Right, so it's yeah, so it's I guess it's probably a signal, but it's a very noisy signal, which is not. And
Yeah,
again, that was Llama 7TB, right?
Yeah, Llama 7TB. But importantly, like the way these models are trained, right, is they're trained on predicting next token, and so kind of a lot of the times they kind of dropped in the middle of the document. I mean, okay, like in the beginning of the document, but document may have some context of like being located on some website, but they kind of need to like start predicting everything without knowing what it is. And so similarly here, it's like, hey, I see chess, so I'm gonna continue doing chess, even though, one token was saying checkers right in the beginning of the document. And so kind of relevant, the relative importance of tokens in the prompt and context, right? Like if you think of it, there's a checkers here. It's one token, like build checkers game, and then there's chess, king, queen,
yeah, king, yeah, board.
yeah, like all of this, and so like when it's predicting a next token, it's like just by the fact that like it is fine-tuned that this is like a system message and you should pay more attention to it, but just naturally there's a lot more semantic meaning. So it's kind of more of a systematic, next token predictor question. And so, I mean, you can keep fine-tuning it, right? You can keep kind of giving it more examples where this is, I mean, and this is where the synthetic data can be pretty interesting, because you can unroll indeed it building something else and then say, this should not be some other application. And so you can train it on, lots and lots of different routes where it's not.
Yep.
To be able to learn to kind of not diverge as part of, just general training procedure. And so in general, maybe, yeah, the kind of, there's one of this process called kind of review. So like, after model done responding, you say like, okay, now review the response of this model as a critic and tell what's wrong with it. And then you use the output of that model to feed it back. So like, okay, now that you have this review and this original context, refine your response. And again, the question here, so one of the challenges, this is usually fine-tuned with so-called instruct data, right? You collect examples of like, either answering questions or maybe doing something like outputting something. This is where things are complicated because we don't have like a thought process of a people usually.
So worth mentioning, instruct is probably also human annotated. You can annotate chain of thought.
Yes, but that's not readily available. Mm-hmm. But that's a good example. It's like having some chain of thought, especially the ones that includes doing something wrong and then backtracking and saying like, actually, I was wrong. Let me go back and fix it. Because again, this model is rarely seen that like, oh, actually, I was supposed to do checkers. Let me continue with that. And so, train it to kind of critically review its own thought process. Yeah, and then there's a little bit more sophisticated than tree of thought as some kind of Monte Carlo tree search, where you are pretty much deciding what node to explore based on kind of some value function that may or may not use a different language model. And indeed, you can train also like another discriminator that is trying to decide on that.
If you have tests, that's outstanding, right? Because at the end of the day, you're like, oh, this passes tests.
Yes.
Send the gradients.
Yeah, and so I mean, all of these methods don't require actually training models, unless you want to, fine-tune it to be better at doing that process. but the model itself usually is not trained on these processes. So I think that the interesting question I've been thinking about is how do we reduce the importance of the prompt, right? Because the challenge is right now, like you need to be very, almost like A/B testing different prompts to find what is working. And then there's some small things that actually can go and mislead the model in the prompt itself. And then the other question is, assuming something like this, the challenge is like when you're enrolling in different alternative, like you learn something here, but that knowledge that, oh, this didn't work is not actually available at the different enroll. So, so in a way, maybe restructuring this, not like on the...
It is available in the subtree, right? Like if something broke here, then all the subtrees know it doesn't work.
Well, I mean, let's say, let's make it not a token, but like, let's say at unroll, it got stuck on doing chess, right? And let's say we even are able to, score that. Well, you're going here, you're starting to unroll a different subtree. And, getting again into chess, because like this, I mean, statistically, right, you just sample a different token, for example, right?
Yeah, well, hopefully. Well, the better, like, yeah, that's not that big of a problem, right? So even if, so effectively we're saying there's an initial state, we know the particular task, and let's say that the model, because of some biases, is very likely to do something wrong repeatedly, right? So chess is a more popular game than checkers, so it is repeatedly going to be doing checkers, right? Or like this idea with like, hey, you need to move the cabbage to another, shore, but because cabbage and nothing else, but because you've been seeing that problem, you have very high chance. But as long as you have any way to test, right, and you enroll sufficiently many, right, so you like enroll it 100 times, and it was saying, hey, go with cabbage, go with cabbage, go with cabbage, but once, it was like, oh, wait a second, go with cabbage and you're done, right, and that is the correct one, as long as you can reinforce it, as long as it has any chance of getting there, tree search will help you.
But this is, you're saying this is at training time. I'm talking about inference time.
Yeah. Oh, yeah.
At inference time, you just wasted 100 cycles on doing the same thing. So the question is like at inference time, when you like go with cabbage, like how do you actually force it out of the? Because most probably it will, go with like in general, these models are like, here's an average of Reddit, right? On average, Reddit goes in this direction. So like, how do you actually sample like some more, different, like semantically different options? So, and I mean, there's obviously methods to do that, but it's specifically important in this kind of approaches where if you want to go get some different ideas, like you're not gonna, keep hammering, which again, this is what we see. The behavior it does, it's like it keeps hammering on the same idea, thinking that, okay, well, if I do it just, a little bit differently, it's going to work. But yeah, I mean, the other approach is indeed like training it to give sufficiently different approaches.
Right. So in general, the experience of using a model to critique something without specifically training it for critiquing that particular aspect are like at best okay, right? So it will tell you something meaningful and it will spot the most obvious things, but it's
that's the same model.
Yeah, it's so like I would say, I mean, these two are specifically benefiting from a critic.
Yeah, from a separate critic.
It would be much better if the critic is trained.
Yeah. True. I mean, you can also then a chain of thought, you can train it in this way, right? That's kind of the difference. This is like, is this the inference time or this is a training time where you use it to improve your direct chain of thought? Because obviously as a person, we're doing some kind of search, but it's all in linear fashion. It's like, well, let me think about that. Actually, that's wrong. Let me go back.
Well, yeah, like you can think of, like if this is your tree.
Yeah, that is continuation of that.
Obviously, tree of thought is convertible to chain of thought with like this, right?
Yeah.
So like, so you have all of them, all of these things in your, well, probably the order would be different, yes, but
like
it's
this, and then like this, and then maybe this, and then
you're like, hey, here's a problem. I will use dynamic programming to solve it. And you like think about it for a while. It doesn't work. Then you try something else, and like maybe dynamic programming was not a bad idea.
Yeah.
But yeah, obviously, I'm not literally backtracking my brain to the previous checkpoint. That would be cool.
But it's kind of what generally is happening right now when you're like redoing the prompts, right?
Imagine you can unroll your brain to before you saw the debates.
That's a separate life. Yeah. Okay. What else we can dive in here? Yeah, I think a lot of it is then ends up being in kind of just having very convenient infrastructure to run fine-tuning, being able to run these experiments.
So part of it. So one interesting thing here is that having a way to measure progress is helpful for both training and at the end of the day at the inference time, right? So if we have a data set where we have a definitive way of saying that is the correct result, right? Like let's say we're trying to solve competitive programming, right? For every problem we have tests, we know exactly when it's solved. It is much easier to experiment, right? First of all, you can measure progress. You just run, you have a holdout set of 1,000 problems, which hopefully is not in the training set, and you can test, right? And second of all, things like tree of thought suddenly are way more easily trainable because now you have feedback. You can say, oh, I solved the problem. I can backtrack and give reward. So, sort of like, when you do game of Go, you know that you won. You can unroll positive reward. But like if you want to build, when you work on general purpose development, right, you say, well, I want
a website.
I want a website that is like Notion, but different, right?
but on chain.
Yeah, you can. Yeah, but on chain. You can have some tests to test sanity, right? But it's much harder to have a comprehensive suite of tests.
And it will be at the end, the user will be interacting with it, explaining what exactly they actually mean, and making some decisions.
So I think here it sort of goes. Here I think one thing is that it helps to have a more generic agent solving both things that like adjacent but different. Like let's say our ultimate goal is to build applications, right? Not just let's say it is actually the goal. Right? So you want to be building like Web3 applications, and I think smart contracts in this sense are somewhat easier. With smart contracts, you can like generally you have a very comprehensive set of tests for smart contracts. That's the whole goal, right? But then you have a web UI for it, and you mess something up in the UI, and people say, hey, I want to swap, I don't know, 10 NEAR for whatever, for 10W NEAR, but in reality conversion goes wrong and you swap 1,000, and yeah. So the idea, what would help is if you have a combined data set where a big part of it is testable and has good tests, right? So the model can continuously improve, and another one is sort of adjacent and improves together, right? It also would be, there's like a meta level. You can teach ideally you would have some sort of system that interacts with the result and provides feedback. So that's something that, especially as you move to the websites, GPT-4 might be decently good at it right now, but if we think of open source models, there isn't that many good, if any, visual open source models, right? And when they will come up, I'm pretty sure they will be trained like on Leon or JSON datasets, right? So it will not have that much of interacting with UIs. So that's something that I think would be pretty cool if we can have. Again, this is something we're probably going to do in the foreseeable future, but like a good data set and a model fine-tuned on it of people interacting with the applications, providing feedback on their experience, that can then be like, like you have like a good critique model that is actually properly trained to criticize, right? So you have an app, you like plug it in then, and it's like interacting with it, saying, hey, it's not what.
Yeah, this button doesn't work, or like this flow doesn't make sense. Yeah, so pretty much like what you're saying, there's a whole, like training a critics / summarization are the steps where, okay.
And where you can thoroughly test, you should thoroughly test. That's that generally should be the case.
Yeah. Yes. I guess thinking more though, how can we upskill some of the existing open source models to have kind of a more robust thinking?
Well, better data never hurts.
Better data, more reliable data. I mean, we discussed last whiteboard, right, that like currently the model is trained on kind of random set of data at all times. So a more curriculum where you actually find where it's not getting it and fixing that.
But on NEAR, people have been experimenting with annotating data for a while. There's multiple good ecosystem projects right now working towards it. So we will have a pretty large effort towards annotating a bunch of data to open source it later. And generally, I think data annotation is generally a very interesting area because it requires a lot of interaction between people. Like ideally, if you want to annotate millions of examples of data, and it requires people doing it, you have to like build a scalable system where there are going to be a lot of malicious actors without an ability. It's almost like designing a blockchain with the difference that on blockchain at least certain things are verifiable. Like like I can say that this message is signed by that person, while in annotating data everything is subjective, right? So you have thousands of people doing subjective work, verifying subjective work, and obviously like for a particular, like there's a there have been some large scale efforts, and like you will never be able to document every single possible interaction, right? So people need to converge to some level of agreement between themselves, right? So it's a very interesting problem, which is very similar to what we design in blockchain. So we have, like, I would like to believe that we can do it better than centralized companies. Better, cheaper, and more accessible, right? Because, like,
it works at like fraction of the cost.
Yeah.
Because all of the marshalling of kind of money happens on chain.
Yeah, and like a lot of orchestration can be done on chain as well. So it's I'm a big believer that blockchain-based data annotation tools will win eventually against the centralized companies with like armies of salespeople and Yep. What else was it? Okay, so another interesting idea we were discussing today, more in an AI space than blockchain. We will be jumping between the two. At the end of the day, there's no blockchain without AI. That's something Illia was mentioning. He was like, "Hey, how can we escape from the
prompt hell?"
From the prompt hell, and one of the engineers here with us in Morocco, he suggested an interesting idea where, so this is your prompt, and so prompt engineering is a big thing, right? Like you try different prompts, and some of them work better, some of them work worse. Anyway, you come up with a prompt which is somewhat good, but then you have some other way of measuring the success of your model, right? So like, let's say you actually have a data set which has a lot of tests, and ideally we should have a bunch of those. So then you start training, and when you feed the prompt into the transformer, by design, right, it will go through the layers and it will like populate those keys and values that like future things will attend to. It would be nice like to select and clone it.
I think it's also maybe bigger for
Oh yeah,
the
yeah,
camera.
probably. It's probably like a tiny, yeah, I guess. Anyway, and an interesting thing here is that for a particular prompt, which presumably will be fixed throughout your usage of the model, those keys and values are always the same, right? So one obvious thing that I'm pretty sure almost everybody does today is you can just cache them, right? You compute them once, you drop them into memory, and then whenever you actually use your model in practice, you do not actually unroll that. You just start from the next token. However, right, and so instead of having a full transformer here, you can imagine now that you have just a bunch of keys and values, and the actual layer is not executed, right? So like, let's say my transformer has 4 layers total, right? So this is the actual unroll, right? So this is first layer, second layer, third layer, and so they are outputting QKV, etc. But here, before the prompt is, you have those Ks and Vs, but this doesn't exist anymore, right? You do not actually compute them. They're just constants, right? KV for each layer. So now the cool thing is that, like, when you train the model, the gradients flow through these things, right? But the gradients update this block, like MLP and attention that compute them. But here instead, now that this block is gone and K and V are constants, you can fine-tune the constants themselves, like the actual vectors. So
for a specific problem.
For a specific problem, right? So with a downstream task, right? Like you unroll it, and you're like, oh, it passed all my tests. You send the the gradients back. They update your weights, probably Laura's.
Well, or you don't. That's
or even maybe you even don't.
You fix the model, so the weights are the same.
Yep.
You're just saying actually there is no actual like effective prompt. It's just some set of vectors that
so maybe
model
initially
can attend to.
Maybe initially you computed them by enrolling transformer for a prompt.
Yeah.
Or maybe they're completely random.
Oh, I mean, if you wanted to find
I guess
answer.
yes. To increase the chance of ever getting to a successful trajectory, right?
Yeah.
But then you can fine-tune the things themselves. So at that point, assuming your prompt was at least somewhat good at the beginning to get to any success, the goodness of your prompt doesn't matter anymore because the prompt just becomes the perfect prompt for this particular problem, right?
Yeah.
And not just at the input level, right? At every
it's like
level.
whatever the key value is that whenever you need to output the next token will be the most useful.
Yeah.
Which is contains instructions and whatever else it can.
Yep. And if the model, if you don't actually send gradients, right, then you just like drop one prefix at another. I guess probably as expensive as plugging in lore on top of it, but yeah. So that's something interesting, relatively easy to try, right? So like I guess the closest example where we can play with it is with the summaries that I was showing at the beginning. Once we have them, there's a good chance we will try this.
Yeah, we can. Yeah. One, we can LoRa, which I mean, one of the challenges was in general fine-tuning, right? That it gets better on the set of data that you show it to, but it gets worse in some other places you don't even know where. Speaking of, if we try this and it doesn't work, you can be sure we will say it, unlike everybody else who tries, fails, and does not. Like that's something that should become a norm. A norm, yeah. Like if you try something it doesn't work, it makes sense to say, hey, we tried this, it didn't work. This is how we tried it. Like maybe we messed it up. Yeah. Yeah, I mean, going back to the infrastructure, one of the things we're trying to do is like, how do we keep track of all the experiments, including failed ones, and then you are able indeed to have like, hey, what was this? Okay, well, this was actually this code with this data, and you can see kind of the outcome, and maybe this outcome is an insight on this doesn't work, maybe it's, has a bug in the code or some other failure. Or maybe data, is too noisy. And so ideally, you should be able to have this log and be able to easily navigate all of them. And then, have this tooling open for everyone so everybody can collaborate.
Yep. Also, are we talking about the router?
I mean, not yet, but
okay.
Yeah, that's going to be part of the.
I didn't mention anything.
You unroll back your
context. and the context of everybody watching.
Yeah, but yeah, a few weeks. Yeah, so I think, the interesting question here in general, right, like is there is a problem that kind of like structures the process of the further kind of processing data and generating. And the other interesting question, the question I've been always trying to think through is how do we actually, like as people, we're not just, unroll, and then maybe collect the data and fine tune. But, we kind of trying to update our weights somewhat on the fly. And so if you can imagine, we have these models running with lots of people actually hammering on them. Even if it's just like, okay, well, let's take all of this unrolls and kind of fine tune. The problem is the signal is not always there. But how do you actually extract the signal and update the model? And going back to the problem of fine tuning, right? Again, if you there's some distribution of knowledge it has, right? And then you wanted to solve some specific problem that maybe it's not that good at, it may lose some of the.
Yeah. Oh, by the way, this is something we were discussing today, right? That when you do LoRa, you inevitably forget something, right? Like naturally, if you mess up with the weights in which your knowledge is stored, eventually some of them
will forget something. Yeah.
Yeah.
But this adds new weights.
But if you add new weights, it doesn't necessarily mean that the performance will not be regressed, right? So it is very likely and very possible that certain values in these keys and values will inhibit particular behaviors which you might wanted to preserve. They just weren't in the data set. But I think it is fundamentally the case that if this is what you fine tune and not the weights, then fundamentally model is as capable as it ever was because the model hasn't changed, right? It's extra, strictly new data that you fine tune that naturally fits into the model. So it's Illia. Yesterday, Illia, out of nowhere, stood up and philosophically said, I want a function G such that if you feed into it a model and a batch of data, it yields you a new model such that the new model knows everything that the original model knew, plus the information from the batch, right? And feeling very smart, I was like, well, this is obviously impossible, because then by doing it repeatedly, you can learn infinite amount of data into the finite size of the model. But I guess, obviously, yeah, there's nothing in this problem statement was requiring the model to remain of the same size. Right? And this is sort of, that's a version of the function G.
Yeah.
Yeah, so feeling smart and being smart is not quite, quite the same thing.
Yeah. But the point of this is then, you're able indeed to maintain the knowledge and skills, but also potentially grow them. But I guess, the other question is how to evaluate this, that it preserved.
Well, then, assuming you know what you want not to forget, just have a benchmark.
Yeah.
Have a universal benchmark which tests the whole set of things you think are fundamentally important to know. Then if it regresses, you're like, well, too far.
Yeah, except, I mean, if you want to train this function G, then that's a expensive process to evaluate every time at every step. So,
well, you can hypothesize. You can hypothesize that as you train, especially let's say we're specifically training LoRa, right? So we're not saying it doesn't forget everything M knows, it just doesn't catastrophically forget important things. Then you can hypothesize that to random perturbations to the weights, the level of forgetting is the same for a particular distance with the new model, right? So like you use some sort of distance, like a KL divergence or whatnot, and you you do some experiments and observe, if KL divergence is up to some value, the model doesn't catastrophically forget stuff. Otherwise, it does. Then then you can cheaply say. Moreover, like as you train, you can like push it, like they do with PPO.
Yeah, you add a loss pretty much.
Yeah. I guess that's exactly the problem they were fighting, right? When you do RL.
Yeah.
Then were samples so small, you just.
Yeah, and this goes back. I mean, this can you can express it as a RL problem where you have a policy.
I mean, it literally is an RL problem.
Yeah. And it's almost like there's some kind of A-star algorithm with some Q-learning. Yeah. But yeah, I think like to summarize the kind of we're building a set of infrastructure that is going to be open source and available to everyone to use. So you can track experiments, understand how experiments went, potentially run some on some shared compute that's provided by some decentralized providers. Then you can use that inside this kind of agent framework to either actually try to solve your problem or generate unrolled data, and that goes to crowdsourcing. And then from there, you can hypothesize some experiment around new data that would solve for specific capabilities, while also benchmarking for everything else, and test it out.
Yep. What does NEAR.AI do? I guess we didn't quite. I mean, we have a blog post, right? But I think it's worth mentioning what we do in short term, right? So, I guess the short term goal is we do want to get as far as possible in helping people build Web3 apps. Right? So there's a certain there's kind of a chicken and egg problem where the number of Web3 apps is not that large, and so when the users come into the Web3 ecosystem, they're like, yeah, it's fun place, but not much for me to do here. And then therefore, the hypothesis is if we had a bigger ecosystem, more users would come. But developers are like, hey, the number of users is not yet that high, so right. And so Web3 remains relatively niche, right? But if anyone can come and say, hey, I want to build, like the point here is, having a Notion which is decentralized would be outstanding, right? So today, like Notion, you use Notion, 5 years later, that will be gone, right? There's no chance of, I mean, there's a chance, but there's definitely a chance of Notion not existing 5 years from now or 10 years from now, right? So like, it's like short-term ephemeral stuff. And like, it would be so cool if there was a version of Notion that snapshots to chain or like to some sort of decentralized storage solution, which I know is gonna survive. But building it is very involved, right? Like building Notion in general is not easy. That's why the competition is relatively lacking even in the Web2 space, right? Especially, like I think the first 80% is probably relatively simple, but like making it polished and whatnot. All right, but if anyone can come and say, hey, I want to build Notion version on chain, and some sort of AI agent will get you 90% there with guidance from you, that will be a very different world, right? So suddenly you can build much better
Well, in general, faster like go to market as well, right? Because like, oh, I have an idea, type it in, boom, you have a first version of the app, and now you can test the idea with an app.
Yeah. And every day it looks less and less like science fiction.
Yeah, we started on this problem in 17 when
Yeah.
it
When it was more science
fiction.
fiction, yes, but like now, even just like observing, this example I gave at the beginning with an agent writing code, like it's uncannily close to being very good, right? It's just like it messes up every now and then slightly, but the delta to be close is very small at this point, and it will happen.
I mean, even on the simpler programming competition problems, it's already doing like 30%.
Yeah.
On
yeah,
A/B,
so
and so again, compared to when we started in 17, it was doing 0.
Yeah. So like generally every day, what was it? The website we were playing with today, WebSim.
Yeah.
Right. So like, this website, I will write it down. Yeah. We the only reason we know about it is because it's using what, Open Router.
Yeah.
Yeah. So there's a website called Open Router, and I guess WebSim was one of the bigger users. So we were like, well, what is it? And the first several interactions with WebSim.ai, it feels like you have a portal to another universe from which they ship stuff to you, because it just, I still have no idea how this works. Right, so like I will give you an example. We had access to Devon, like to the actual one from Cognition, and I wanted to build a game of rock, paper, scissors with spaceships, and it took me, it built something eventually, like it wasn't a complete flop, but it took me a good part of a day, following up. And then in WebSim, I just said, rock, paper, scissors with spaceships, and I just loaded in 15 seconds a fully functional game with much better animations. It just, or like one thing, given the example of chess and checkers, I said, build me a game of checkers where every piece is a chess knight. And again, 15 seconds later, it did exactly that. I didn't try with Devon, but it would be an interesting thing to see. So yeah. But the example is, every now and then in the modern world, you wake up to the news of something that yesterday would have felt like science fiction, like Sora when it came out, right? It was like, I mean, it still didn't come out technically, but right, it felt like something completely impossible. So I think the world in which you just go and say, build me this smart contract on NEAR with a web UI and middleware is pretty close. And there's a good chance it will happen before general purpose developer, just because the scope is so contained and smart contracts are much smaller, way easier to test, right? So like some sort of tree search is pretty likely to yield good results. And because we have access to such a, like the data wheel, where we can, very quickly spin up projects where people who know NEAR and like NEAR and want NEAR can very quickly, put together a bunch of good examples. So yeah, I'm quite optimistic that one will work out relatively short term. But longer term, as this beautiful song earlier on suggested, longer term, that's like, just a step towards having a whole ecosystem. Like ideally, yeah, everything, data sets, inference servers, training servers, data. I said data, right?
Yeah.
Still data sets.
Pretty much, yeah. Like I mean,
experiments,
I
data
posted
sets.
that, yeah.
It should be all.
I mean, there's kind of a data layer, kind of model,
Or
and
experiments, yeah.
infra layer, and then there's an application layer, right?
Yeah.
And so in data layer, you have, crowdsourcing, you have, data acquisition.
Yeah, data contribution network.
Yeah, you have some synthetic data probably. And some form of curation as well. And there's more stuff here, right, obviously. And then here you have compute, kind of broadly. You have inference, training, the models themselves, kind of customized models. And then in application layer, you kind of have all of the fun stuff that people are building. And so you want kind of the full stack, right, to not depend on, this guy's going to just, like, whatever. Their API was down, for example, and, like, all the application stack wasn't working. Mm-hmm. And similarly, you want, be able to access data or both cheaper and kind of in a different way where, creators potentially getting rewarded versus it's all, free for all. But again, this is kind of more of a, this should be a better stack to build on.
Exactly.
Not just, hey, this is like, because of values, we want this. It's more, this is a better way to do it. That's why we're building it. And it's going to be, cheaper, more accessible. There's going to be multiple versions of different pieces because they're actually, having a healthy competition.
Incidentally, the existing stack is not that easy to use, right? I don't know what's the reason for that, but like setting everything up, even installing Python
is on the Mac.
On the Mac, yeah, is not that trivial, right? So it's like a rare situation where you can build a decentralized stack, and you will not be fighting an uphill battle against a very, like
Mac level, everything
very streamlined process of the centralized solutions. So I think that's
well, because in centralized it's also like kind of different, right? Like you're using like compute from AWS,
yeah.
The inference is here, the data in general, you need to talk to salespeople, you need to get API for $6,000 a month, etc. Right? So you generally don't have like a good setup unless you're in one of the big companies where this is all kind of given as a one thing.
Yep.
So yeah, I mean, one of the kind of this experiment tracking and in general being able to ideally spun experiments in this setup is something that like internally some of the organizations have because it was worse for them building when you have like thousands of people together working, but it doesn't really exist in open source because every team in themselves kind of are having some version of that. And so you can have like a shared version that everybody's integrating with if you work in open source way. Yeah. But I mean the in the blog post, right? Kind of the idea that the AI developer is also leads to
researcher.
Yeah, researcher. And this is kind of, I think there's a lot of the conversation right now about this. I think I just saw another thread by Jeremy Howard about this. That's like the current LLMs are just just giving you statistically most probable thing, and so yeah, clearly it's not very good at like exploring different options yet. And so, but you for sure will need some kind of logical reasoning, and this is where the formal systems come in.
Yeah.
I mean, you will need some way of kind of getting unstuck and figuring out alternatives, like sufficiently different alternatives. So like this kind of search, exploration, which again we already see we kind of need even on the simpler examples.
Worth mentioning, this is brainstorming. We have no idea how to build the AI researcher.
Yeah, but this is like, I mean, we see these things are needed even for AI developer, right? And they're clearly need for AI researcher.
Yep.
And so
but I think generally, like making agents creative, agents in general. Some influential figures on Twitter say it will not be LLMs. Whether it will be LLMs or not, hard to say, right? But like we need creativity as someone said that like Fermat spent 20 years of his life learning math, and then I don't know how old he was. Anyway, the rest of his life creating math. So it's something that No idea yet how to go in that direction, but that's like a North Star to make sure that eventually the systems we create are capable of
advancing science and humanity. Yeah, but starting to focus on these two sides to make sure we're actually making progress. How are you doing on time?
It says 32 seconds. Oh, 1 hour 34. Okay, yeah.
All right. Well, hopefully this was good and educational. As always, we just kind of brainstormed and discussed some of the things we're working on, and we're going to continue doing that, especially when we are in person, and as well posting more stuff on the blog and releasing some of the code and experiments from this. So stay tuned, and thanks for joining.
Yeah, hope it was fun.
Yeah.